Alright, good day students, welcome to the Microsoft Academy YouTube channel. Now we have a topic, Cyclotron Effect. So quickly we are going to see what the Cyclotron Effect is all about. Now in the Cyclotron Effect is gotten from the idea of Lorentz. So what you observe is that if an electron is drifting into a magnetic field, that the electron is going to spiral about the magnetic field, thereby causing a cyclotron effect. So the cyclotron effect is simply the spiraling of the electron in the magnetic field. So this is what we have. Let's look at an electron that drifts, and we have a magnetic field, a uniform magnetic field positioned at this point. Now if this electron drifts into this magnetic field, now this is the direction it moves with a velocity, and this electron also has a charge. So as it drifts inside the magnetic field, instead of it to keep on going forward, it will spiral about the magnetic field. So that spiraling of effect is a circular motion, so which means that it will also have a radius. Okay, so now we observe something, that there is two forces here. One is the magnetic force, and two is the centripetal force. Remember, the magnetic force is as a result of the magnetic field, while the centripetal force is as a result of the rotation effect. So that inward force that keeps the body in rotation is the centripetal force. So there will be a point as it keeps on spiraling, we notice that the centripetal force will equal to the magnetic force. So that is the only point that causes this cyclotron effect. So what is centripetal force? From our elementary physics, we have that the centripetal force is giving us mv squared all over r. So that is the centripetal force. Then the magnetic force, we already have said about it. We say it is equal to q v vb. So when you look at this formula, you see that we have some things in common here, which is the velocity, right? So v, we cancel one of these v, and we have that qb is equal to mv all over r. So I can make v the subject formula, so that if I cross multiply, I'll be having that mv is equal to, this will cross multiply, we have qb r. So one can make v the subject formula. I divide through by m, I divide through by by n. So m cancel out n. So we have that v is equal to q b r all over n. So that gives you the velocity of the electron in a cyclotron effect. Now we have gotten the velocity. We can also get other relations like the kinetic energy of the electron. How do you get the kinetic energy of the electron? We have that kinetic energy is given as half mv squared. That's our elementary idea of the kinetic energy. So for here, we already have the velocity as given as this. So one can substitute, and in place of v, we are putting qbr all over m. So this is qbr all over m. Now remember, there's a square here, right? So we put a square. So this will be squared, 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 and also squared. So that means we have half m. So this is q squared, b squared, and r squared all over m squared. Now do you observe that m, we cancel one of this m? Okay, so if you do that, what you have is half. Then this will give us q squared, b squared, r squared all over m. So one can decide to rearrange the formula as you want. So I can decide to write this as 1 all over 2 m bracket open q b r all squared, because they all have squared. So we factor out the square, and it gives us the kinetic energy. Now we have the kinetic energy. Another factor we can get is the period, the frequency of the cyclotron. Now to derive for the period, the frequency of the cyclotron, we go back to the formula which says that V is equal to RW. So this gives us a relationship between the linear velocity and the angular velocity. So one from here can see that our W is 2 pi f, right? So if you substitute here, our V becomes arrow. So this arrow now will be using capital arrow since we have started with capital R, which is the same radius. So W is now 2 pi volts f. I can divide through by your V, right? So your F, so that we have F will be equal to V all over 2 pi volts R. So I can calculate the frequency. So the period has already been gotten. You can substitute as well to get the period from here. The period will be 2 pi R all over what? V. So that is when you take the reciprocal. So this one will come up, this one will come down. So you have the period as this. So your V is already from here. You calculate your V here, make your substitution. If you should do that, that will give you QBR all over N divided by what? 2 pi volts R. So you have this. Then you can as well make your substitution for V here. You'll be having 2 pi R all over, my V is QBR over what? Over N. So M can come up here. You'll be having 2 pi M R all over Q what? QB what? R. So you can see that the radius cancel out the radius. So you now have that the period is equal to 2 pi M all over Q what? QB. So the same way, I can say the frequency is also, from here, you take the reciprocal, you have QB all over 2 pi volts N. So that is the frequency and the period of the word cyclotron. So this is the analysis of the cyclotron effect. So in the next class, we look at calculations of the cyclotron effect. If you are new to the channel, subscribe to the channel, click the notification button so that you will see other videos we'll be posting on physics, chemistry, and maths. Thank you.